Okay, perfect. Give me a thumbs up if you guys are ready to get going and I'll have a pen and paper in your hand. Awesome. Okay. So over the last while, we've been talking about reducing trig ratios or trig uh, angles using the reduction formula. And an example of that would be something like the sine of 330 is the same as minus sine 30, but the cos of 330 is the same as positive cos 30. And that's got to do with the quadrants and the fact that we can actually deduce some rules. And so what I want to point out is that in the last couple of lessons, we dealt with quadrant 2, 3, and 4, but we also have to deal with what happens if it keeps going. So if you have an angle and it goes past 360, or maybe it goes around a second time or a third time, how do we reduce those? And also what happens if you're reducing an angle which goes in that direction, so the negative direction? And the good news is it's really straightforward. So let's say I take the sine of 450. If you think about the sine of 450, you can rewrite it as the sine of 360 plus 90. And if you think about that, that is just going to be the same as the sine of 90. Okay, so because you're going to be in quadrant 1, and then it reduces to the positive. So that's what this formula over here is talking about. Maybe if I did it with an even bigger one, we can see, let's say the sine of 750. Now, if I go around twice, I could rewrite this as 720 plus 30. And what that is really telling me is that this trig ratio is 30 degrees away from the nearest horizontal. So it basically goes once, twice, and then 30 degrees. And then the triangle that I'm forming just has a 30-degree angle where the dot is over there. It's basically that angle. And because you're in quadrant 1, you can rewrite that as the sine of 30. But I want you now to try and reduce, let's say, the sine of, no, let's say the tan of 420. Can you please reduce this tan of 420 using the idea that I showed you now, that if you go further than just one rotation, you can just use the nearest horizontal to help you? So welcome to, I see Atlichang, Rulani, Zelinda, Sepang, and a couple of other students who are busy with us, busy joining us. So if we rewrite the tan of 420, what is that going to be in terms of the nearest horizontal? What is the nearest horizontal? I think the nearest horizontal would be 360. So how can you use that to help you? What are you going to get? Now, some of you can do this in your head. You can literally see that it's 360 plus 60, but if you need to, you can write it as 360 plus 60, and then ask yourself, what quadrant am I in? I'm in quadrant 1, so everything is positive. And so this would be written as the tan of 60. And so that's how we reduce angles that are greater than 360. And we just look and we write them in terms of multiples of 360. And then we say, what quadrant are we in? And then we're good to go. Now, the other one we have to deal with is negative angles, but these are actually even easier. So let me just show you how the negative angles work. So if I have the sine of minus 30, I want to not so much reduce it, but change it to a positive angle. the way I visualize minus 30 is I start here and I go in this direction, whereas positive 30 is going the other way. Now, if I do that, the triangle that I'm going to get is going to look like that. And the size of the angle is going to be 30 because it had to go 30 degrees in that direction. In this quadrant, is sign positive or negative in quadrant 4? So I'm saying sine of minus 30 is it's negative. So when we rewrite this, we say, look, this thing must be negative, and then we can write it with a positive angle minus sine 30. Now, using that same idea, if I say to you, what is the cos of minus 30? What is that going to reduce to using these negative angles, the negative angle idea that I showed you now? You're going to get the same triangle, but how is it going to be different? Well, in quadrant 4, cos is in fact positive, and so you will see that you get that. All right. So what we have there is we have a way of changing negative angles to positive angles. Let's just do one more. If I say to you, change tan of minus 60 to a positive angle, what are you going to do? What's that going to be changed to? What's that going to be changed to? So you need to think, where would that angle be? It's going to be in this quadrant. The triangle will look a little bit different, but the angle won't be 30 anymore, but it will actually be 60. And in this quadrant, tan is negative. So this will be negative tan 60. Okay, so what are the skills that you need going forward? So in summary, it's a good little summary here. Any angle, obtuse or reflex, can be reduced to an acute angle by doing the following. By converting negative angles to positive angles, which is what I was just doing. By reducing angles greater than 360 by using the idea of writing them like 360 plus something or 720 plus something and then reducing. By using the normal reduction formula that you were learning about previously. And then the last thing is something called co-functions. Now, I want to know, give me a yes in the chat if you've seen co-functions before. Give me a no in the chat if you've never seen co-functions. I just want to get a feel of how many students have seen some idea of co-functions and how many have not. Okay, so you have some idea. Okay, so I'm just going to go over the basic idea. When you talk, okay, so a co-function is a different way of reducing or changing a trig expression. And a co-ratio uses not the horizontal axis. So up until now, I've been using the horizontal axis to build my triangle. And we say, how far away is it from 0? Or how far away is it from 180? Or how far away is it from 360? With co-ratios, we don't do that. With co-ratios, we focus on the vertical axes, with the primary ones being 90 and 270. And then the other ones, you could also say this is minus 90 and minus 270. But I'll give you an example of how this works. So if you take sine of 50, how far away is the sine of 50 from the nearest vertical axis? So basically, if this thing is 50, how far away are you from the nearest vertical axis, which is 90? How far away are you? Okay, so you're just 40. And you can kind of see this in my thing I used. If that's 50 and this is 90, this must be 40. If I was using that method of rewriting it in terms of the thing, I would just say sine of 90 minus 40, because we know 90 minus 40 is 50. So it's just like saying 90 minus the green bit gives me that. And so some students like to write it in terms of the axis that they're using. And then you know you're using 90. Now, what's different is you ask yourself, is sine of 50 positive or negative? Sine of 50 is in quadrant 1, so it has to be positive. But here's what's different. If you are using a vertical axis, you do not write down the same trig ratio. You write down the co-ratio of sine, which is cos. And then what you do is you write the angle that would have been in the triangle with the vertical axis, and so you write the cos of 40. So what this is saying is that the sine of 50 is the same as the cos of 40. Just put that in your calculators and check for me quickly. Is that true? Give me a T if it's true. Give me a F if it's false. So the sine of 50 is the cos of 40. Okay. I want everyone to try and do, using the idea that I just showed you and using the idea that you go to the nearest vertical axis and you have to change from the one thing to the other. The co-ratio of sine is cos. The co-ratio of cos would be sine. And so I want you to try and do number 2 and number 3 using the instructions on the board, which says write the trig ratios as trig ratios of their cofunctions. So over to you, and then I want you to write your answers in the chat, please. Or raise your hand, and then we'll go from there. So when we think of the cos of 70, which axis is closest to this? Now, I'm going to do it the long way, but I know some of you will be able to do this quite quickly. Well, actually, I should teach it to you. I mean, I just say, I know it's 90, and it's 20 degrees away. Now, I know cos of 70 is positive. What's the co-ratio of cos? It's sine. How far away is it from that? It's just 20. So number 2 is positive sine 20. What is number 3 going to be? What is number 3 going to be? Number 3 is in a different quadrant. It's in quadrant number 2. And so if I wanted to, I could rewrite it as 90 plus 10. But luckily, sine is positive in that quadrant. And so because sine is positive, this stays positive. I change this to cos, and I get plus cos 10. Okay. Whether it's positive or negative comes from the original item. And luckily, in quadrant 2, sine is positive, which is where sine 100 is. Okay, try and reduce the cos of 140 using the nearest vertical axis and the co-function of cos 140. It's getting dark in it. Let's have a look. So number 4, if I'm feeling a bit unsure, I would write it like this so I can clearly see how far away it is. But I also need to check what quadrant am I in. In quadrant 2, cos is actually negative. Then I say, what's the co-ratio of cos? It's sine. And then I'm going to say it is that. Now, the things to watch out for are whether something is positive or negative comes from the original ratio. So you don't ask, that's important. Like this comes from the original ratio. And then the other thing is to remember that we're using the 90 instead of the 180. Now, I want to add two custom examples that you have to take this idea and extend it. So I want you, number 5 is the sine of 260. So I want to see, can you reduce that using the same wording of the question? And number 6 is the cos of 280. Can you reduce that using cofunctions? Off you go, and then put your answer in the chat when you feel comfortable. And remember what part of town you're playing in here. It's 260 and 280. So that will change things a little bit. So minus 10. Now, is this going to be positive or negative, do you think? I think it's going to be negative because it's quadrant 3 minus cos 10. And then what about 6? Now, I suppose I could say, look, it's 10 degrees away. Is cos positive or negative in quadrant 4? It's positive. I know I need to change from cos to sine because it's a co-ratio. And how far away is it? It's 10 degrees away. So that would be the really quick way to do it. Maybe plus sine 10. Okay, so this is the basic way that sometimes if we don't use the horizontal axis, if we use the vertical axis, we say that we're reducing using co-ratios. And you need to remember that when you use the vertical axis, it's a bit more complicated, but it's also doable. And you only do this when you have to. Given a choice, you would always choose to use the horizontal axis and the reduction formula, but sometimes you're forced to use the co-ratios. So taking the idea that we just did, in fact, let me just give you a bit more time. Give me a thumbs up if you've had enough time to look at the answer, understand it. Give me a thumbs down if you're not ready to move on. Okay. So if we take this co-ratio formulas in the same way as our reduction formula, we could rewrite the sine of 90 minus theta. It's in quadrant 1, so it's positive, and it would become the cos of theta. The cos of 90 minus theta, that's in quadrant 1, so it's positive, and it would become the sine of theta. I want you guys to do the next two for me. Can you simplify the one in yellow? Can you simplify the one in green? What do you get for, we'll call this 1, 2, 3, 4 if you want. Or let's call it A, B, C, D. So C and D are what I'm asking you to help with. C, D. This is in quadrant 2 where sine is positive. And so that would be plus cos theta. What's the last one going to be? What's the last one going to be? So in the second quadrant, which is where 90 plus theta is, cos is actually negative. And so it would be negative sine theta. Okay, so what have we done in this first 20 minutes? We've looked at angles bigger than 360. We've looked at negative angles. And now we've looked at using co-ratios to change trig things from one to the other. Let's have a look at a exam type question. So I want you to start by trying to simplify this top line. You don't have to finish the question. I just want you to try and simplify this. And that would mean simplifying this, simplifying that, simplifying that, simplifying that, I guess, simplifying this, and simplifying that. So there's 6 little mini questions. Once you have simplified the 6 mini questions, say done in the chat, and then I know I can move on. But basically, this is an old test question, and we basically just say simplify and evaluate. So I'll put the simplify and evaluate. So see if you can do that. I'm going to get some water to assist me. Okay, so just give me a done in the chat when you are done. I haven't finished all those conversions. I did the ones I've colored in, I finished, but the other ones I just set them up. And I want to know when everyone is done doing their conversions. So the first one has to be cos theta, because I'm in that quadrant. Quadrant 1, 360 minus 45. That is going to be in quadrant number 4, which means it must be negative tan theta. The cos of theta can stay where it is. The other cos of theta can stay where it is. This is going to become minus sine 60, and the sine of theta can stay where it is. Now, there are a couple of things that are going to cancel out. This and this are going to cancel out. And there's also a negative on the top and a negative on the bottom, so they'll also cancel out. And what I'm then left with is the cos of 30 times the tan of 30 over the sine of 60 times the sine of 30. Now, I don't know if you guys spotted this, but can you see that we have a cos of 30 and a sine of 60? And actually, you could change the yellow or the green one using a co-ratio to become something that cancel out. Which one would you change? Would you change the sine of 60 or would you change the cos of 30? Oh, why minus tan 30? Oh, it's not 30. It's not, sorry. That's me just being on autopilot. So that should be 45. Thank you for picking that up. That was me just making things up. Thanks, Atlichang. Thanks for spotting Tapang. I appreciate that. We are rock and roll. We are good. Let's just make sure I didn't make any other silly mistakes. Okay. I would take the sine of 60 and change it to its co-ratio, which is cos. So how far away is it from the nearest vertical? It's 30. And so I change that to the cos of 30, which is awesome. So that becomes tan of 45 equal over the sine of 30. Now, the tan of 45 is actually a special triangle, and the special triangle looks like this: 40, 45, 1 root 2. The tan of 45 is actually just 1 over 1. 1 over sine theta. Give me a score out of 10 of how well you understood this last question, where 10 is perfect, 5 is like most sort of okay, 0 is like nothing. Give me a sense of how well you understood that question. Okay. All right. So what we're going to do after the break is we're going to keep practicing questions like this. So this is all we're going to do after the break is consolidate, consolidate, consolidate. But before we do that, we need to take a break so that our bodies don't feel like we're abusing them. So I want you to stand up with me, turn on your cameras, and let's do a bit of a body unwind, because otherwise the problem is our brains just start to go into autopilot. And we know when we're on autopilot, we just don't learn as well. So yeah, let's just stand up for a second and take some nice deep breaths. Breathe in. Breathe out. Okay, one last one. Okay, then I want you to loosen up. So what you're going to do is just shake up your arms, get them nice and loose. Shake out this arm, shake out your leg, shake out this leg, and shake out whatever you can just to get your body nice and loose. Okay, then let's roll our shoulders back. Roll the shoulders back. Roll your shoulders forward. And then put your arms to the side. Just do little small circles. And going forward this time. And then change direction, go back. Okay, then shake up your arms one more time. And let's go to triceps. So stretch out your triceps. Especially if you're leaning forward, they can get a bit sore. Switch to the opposite. And, oh, that feels good. And then just shake it out one more time. Okay, then the last bit of our mini brain break is some heart pumping action. And for that, we're going to do this one, which is the jumping jack. And we're going to do 15 of them. And we'll start in 3, 2, 1. Let's go. 2, 3, 6, 7, 8, 11, 12, 13, 14, 15. And that is that. Ooh. And then I want us to do a little bit of a puzzle. So what you need to do for me, just to let your brain unwind even more, is I want you to try and make 24 using either of these two cards. And if you're able to do it, please just put it in the chat, and then you can claim the glory for yourself. So over to you guys. Can you make a 24 for me? Can you make a 24 for me? Okay, Rolani, let's have a look here. 6 times 5, and then 3 plus 3 is 6. And what do you get if you go 30 minus 6? Rolani, you are the winner of the red card. Would anybody like to have a go at the blue card before I move on? Rolani, you are the champion winner at this stage. Unless anybody can solve the blue, then we could have a tie winner for tonight. I'll give you a hint. 7 times 4 might be important. It wasn't a 9. No, it was a 6. This line over there is always at the bottom of the number. Oh, Rolani. Okay, 7 times 4 is 28, and then minus 2 gives you 24. You are our Maths 24 champion for today. Well done. Okay, so back to the land of trigonometry. What have we done? We've learned about these tools, but we need to practice this skill. So we are going to choose, let's have a look. Let me see if I can zoom in a bit more easily and preserve something here. I want everyone to try and do number 4. So number 4 is this one. And I want you to try and reduce this, simplify without using a calculator, which is code for say you're probably going to use special triangles. I want everyone to give a go at number 4. I want you to say done in the chat when you're done. If you are confused or if you need some help, I ask a question about something, or just put your hand up, and an audio question is probably the quickest. But you're definitely going to have to use a combination of co-ratios and horizontal reduction formula and stuff. So see if you can do number 4 by yourself. Here we go. Otherwise, yeah, I'll scan for questions in the chat. Do that. There's a couple of ways you can do this one. So I'm not saying you have to do it like I'm doing, but let's see what everyone gets. Okay, so let's just check. Give me a thumbs up if you understand what I've done so far. Give me a thumbs down or ask me a question about what's on the board so far. Notice how the one in yellow is using a co-ratio, whereas the other one, like this one, is using the horizontal reduction formula. These are all using horizontal. So their trig things stay the same, whereas the one in yellow, it changes. Now, some canceling can happen. So we can definitely cancel a sine 10 and a sine 10 and a cos 10 and a cos 10. We can also cancel a negative times a negative is a positive. So all we have left, from what I can see, is minus 1 over sine 10, because there is nothing else here that can't be cancelled. And the minus sign that is standing out is just this one here. Okay, so I will leave that on the board, but what I want us to do next is I want us to get stuck into number 3, the green one. Can you simplify that one? Simplify and evaluate number 3. Over to you, see if you can do that. And then I wait for your questions, either with a hand up or in the chat if you feel like you're unsure of something. Okay, so you don't have to put the extra step in if you like. So, for example, when you get better at this, you can see that 480, oh, actually, maybe I should actually. My brain is also starting to go. Let me rewrite it because I actually am a bit tired and I'm prone to a silly mistake. So 480, couple of ways we could do it. 360, 120. I could do it like that. So I could do it in 2 steps. Ooh, or okay, there's a couple of ways. I think most of you will probably do this, which is completely fine. I think most people would do that. This, you probably just do that. The cos of 14, you'd probably just leave the same. And the sine of minus 135. what quadrant am I in for that? For minus 135. I actually am in that quadrant, and sine is negative. So I would get negative sine 135. Now, the problem is I still have to reduce these things even further. But just give me a thumbs up if you followed what I did on the top line there. Give me a thumbs up if you followed what I did on the top line. Okay. Now, I'm actually enjoying writing them out explicitly. I know it takes a bit longer and you can go faster than this, but I think I would get to that step and I want to leave it to you to keep going. You have to keep reducing things to make it smaller and simpler. So just keep going. Mm. I'll give you a bit more time, but and there's many ways you could go to reducing this, but I think there's certain things that could cancel. I'm just going to wait until I see a few more dones in the chat before I go any further. I think people need more time to try and do this by themselves. Won't the tan in the numerator be positive? It's a good question. Here's the problem, Rulani. If you look at the angle, it says here plus 120. So if you think of going 360 and you add another 120, it turns out that you're out of quadrant 1 and into quadrant 2, where tan is negative. So because I could have actually chosen, instead of going to 4, you know what I should have maybe done? Or not, I don't have to. But what I could have done is said, that's 360, that's 450. Do you know what? I could have used a co-ratio and said that it's 30 away from 450, but I chose to rather use a horizontal axis. And because of that, I actually, the negative is correct. So just let me know if you understand that, Rulani, why in this case it would be negative tan 120 because of the fact that it's out of quadrant 1. Okay, what do we have that we can cancel? That can cancel, and then that can cancel, and that can cancel. And what am I left with? Oh, the two negatives can cancel. So this is where we have to deal with this. What is the problem at the moment? Why can I not evaluate this thing? What do I still need to do? Tan 120 times sine 60. I need to do something before I can use special triangles. I think it's the fact that the 120 is too big and it needs to be made smaller. And the way I would make it smaller is by saying, look, 120 itself is in quadrant 2, which means it can form a triangle which has a 60 in it. And so it's in quadrant 2. So this would be negative tan 60. And this would stay sine of 60. But before we evaluate that, and we could evaluate that actually, in fact, we can't just go straight to evaluation. We'll deal with identities more in the next one. So this is the triangle that you will use. Okay. And then what do we have? We have the tan of 60 is O over A. So root 3 over 1. And the sine of 60 is going to be O, so root 3 over H, which is 2. And root 3 over 1 times root 3 over 2. Well, root 3 times root 3 is 3. So this is 3 over 2. Ooh. Why is the top sign 60 negative cancelled? Oh, okay. So the way to see it here is how many negatives are there in total? And you'll see that there are 4 negatives. And so the one way of saying it is I cancel this negative with that negative over there. So this one and this one. And then this one over here and this one over here, they ended up being positive. So that's how they got cancelled. So Simtanda, I hope that helps. And then the final answer then is going to be 3 over 2. All right. Now, that is enough questions for one day. What I would like to do today, instead of going right to the very end, is I'm going to give you the link to your quiz for this week. And I would actually like you, I think a lot of you could get your quiz done fairly quickly if you just get stuck into it right now. So what I'm going to do, I see there's a good question. Let me answer that question first. So Sipanga said, "Sir, how would we know in an exam that we're supposed to use co-functions?" Okay, let's go back and look at this. Do you know what? So, Sipanga, you have a choice. And the thing that I made a choice with is, for example, the one that was causing problems was this 480, right? I could have reduced 480 by going to the vertical axis 450. But you know what? I just thought, you know what? I don't deal with vertical axes that often. Let me rather go to 360, which admittedly made it a bit harder because it's now reduces to 120. But then I could just reduce the 120 down to 60 later on. But the honest truth is, Tabang is practice. The more you practice this, the more you know. Look, given a choice, always use the horizontal, but sometimes when you're stuck, you have to use the co-ratio. And someone else has spotted something that is absolutely true, is that what about the minus sign that is chilling out in front over here? That has not gone away, and I've simply just removed it. And so thank you very much, Rolani, for picking that up. The correct answer is, in fact, minus 3 over 2 in the end.